Okay, so question number 5 says when displacement B is added to displacement A, the result is displacement C that has components Cx equals to 3 centimeters, Cx minus 3 centimeters, Cy plus 3 centimeters, and Cz is equal to that. Well, Cz is equal to plus 4 centimeters. Displacements A and B are in the same direction. So A and B are in the same direction, but the magnitude of A is half that of B. Find the components of A. So these vectors are in the same direction, but magnitude of A is half of B. Find the components of A. This one we kind of like I think we can work it out straight. So what do I do? So to begin with, we need to, we can do our, I think this one we can say C, just a bit, type something, with the C is equals to A there. So basically this is what we have. For you to get C, you need to add to displacement A, you need to add B. Okay. If that is the case, we are also told that, of course, these two guys, A and B, they're in the same direction. That's what we're told. A and B, they're in the same direction. But we are also told something. We are told displacements A and B here. Displacements A and B are in the same direction, but the magnitude of A is half the magnitude of B. But we're also told that A, we are told that vector A is related to vector B in a certain way. Is related. We're told that vector A. Can you see that? Vector A and B. Vector A and B are related. They are related as follows. So vector A is related to vector B, as in A is half of B. Vector A is equals to 0.5 B. Is this clear? Is what we have written clear?
Yes, sir.
Okay. Vectors. Vector C. Is the vector sum of vectors A and B. Okay, so now that we know that A is equals to 0.5 of B, we can replace this here so that we have vector C in terms of only vector B. Is that clear?
Yes.
Okay, so we substitute for vector A as okay, here. So this is what we have. After we make the substitution, we have C is equals to, instead of writing A, vector A, we write 0.5B plus B. And that's going to give us vector A as vector A will be equals to how much? So vector C will be equals to how much? How much would be vector C? When you add 0.5B plus B, how much do you get? When we add this 0.5B plus B, how much do you get?
I think 1.5B.
Yes, you get 1.5B. Yeah, I get 1.5B. Okay, so C is equals to 1.5B, like that. Now, we can rewrite this in terms of components, the same thing. Excuse me. We can rewrite C in terms of X, Y, and Z components And as follows. Excuse me. So again, so cx will be equals to 1.5. Excuse me. Hello? Okay, so we can have 1.5 C bx. Just a minute. Okay, so this is what you get. So when you rewrite this vector, in terms of components, we have cx is equals to 1.5 bx, cy is equals to 1.5 by, cz is equals to 1.5 bz. When we look at our question, we have been given the values of the components of C. Let's go a bit up. Here, Cx is minus 3 centimeters, Cy is plus 6 centimeters, Cz is plus 4 centimeters. Okay, so those values we have them. So we know the x, y, and z components of C, vector C of C as, so we have been given these guys. So substituting, we get substituting, we get now, if we substitute, we start getting, in this case, for Cx, so Cx is minus 3 centimeters. Yeah, Cx is this, and the value of Cx is minus 3 centimeters, so we substitute, you get that. Then when you do that, we get equation bx, get bx to be equals to this is how we get bx. So we divide on both sides by 1.5. Whose microphone is that? Like that. Yeah, so we divide on both sides by 1.5. Victor, your microphone. If you're not speaking, switch off your microphone. So we get that, so we end up having, how much will be our bx? How much will be bx? Yeah, minus 3.0 divided by 1.5. How much do we get for bx?
-2.
-2. -2 centimeters. Okay. Next, we calculate for by. So we know by this what bi, we know it's 1.5. 1.5 by is equals to c. From here, c is equals to 1.5 by, so we just write like that. But we know that by is this, plus 6 centimeters. That's by. So substituting for cx, cy, cy not, we get that, which is equals to so we have by is equals to 1.5 by is equals to plus 6 centimeters. Therefore, we can get by as 1.5, 6 centimeters. Then 1.5. Yeah, by is equals to plus 6 centimeters divided by 1.5. So we end up having how much do you get for PY? What do you get for PY?
4 centimeters.
Sorry?
4 centimeters.
How many centimeters?
4 centimeters.
4. Okay. Like that?
Yes.
All right. Okay, what's that means? Next, we work out for calculate BZ. BZ. Now we know not 1.5 PZ is equals to CZ. Then next bit is we do a substitution. There. Then we got our BZ. So where are we? There. So we got 1.5 BZ is equals to plus 4 and 0 centimeters. Then BZ is going to be equals to plus 4 centimeters divided by 1.5. So our BZ will be how much?
2.7.
2.7. Okay. Okay, so we have found the components of B. We know the components of C. The components of C are known. Then you find all the components of B. It's minus 2 centimeters. By is 4 centimeters. Pz is plus 2.7 centimeters. Okay, but I don't think that's what the question. The question is asking us to find the components of A. Okay, so but we know the components of A is related to B like this. That's how A is related to B. Okay, this. So we actually are going to use this and write A in terms of B. The components of A, AX, AY, AZ, we're going to write them in terms of B because we know the components of B. Each of the components of B, we know them. BX, BY, BZ. Okay, so that's what we're going to do. So recall that vector A is related to vector B as follows. Vector A and vector B as related as follows. So we write in terms of components X, Y, and Z. So we can rewrite above equation in terms of X, Y, and Z as follows. So we end up having in AX is equals to 0.5 BX that so we can do this. This vector A is equals to 0.5 vector B. We can write it in terms of components like this. AX is equals to 0.5 BX. AY is equals to 0.5 BY. AZ is equals to 0.5 BZ, like that. And this BX, BY, BZ, we know the values because we have found them. Okay. Next. Next. We get AX with AX as get AX by substituting BY, sorry, BX, BY, BX, which is equals to BX, where's BX? Yeah. BX as follows. x is equals to there. That gives us how much?
-1.
-1 centimeters. Good. Get -1 centimeters. Is that clear?
Yes.
Okay. Next, we go for by. We get ay by substituting by, and by is
Y is 4.
yes 4 centimeters. 4 centimeters. So that is going to give us, just a minute, ay. So how much we get for ay?
2 centimeters.
2 centimeters. Okay. Next, we work out for AZ. AZ by substituting BZ, and BZ we found to be, where is BZ? Here. Two point seven. How much is that? AZ is equal to 0.5 multiplied by 2.7. What do you get?
1.35 centimeters.
1.35.
35.
Yeah, it's 1.35 centimeters. Okay, so you found what you're looking for. So the components of the components of vector A are AY AX is equals to -1 centimeters. AY is equals to two centimeters. Then Just a bit. Something. Okay, there. Are we clear? Are we clear on this question? What we have done and how we have done it? We have tried to use the simplest way we can find. Are we clear on what we have done? So what have we done?
Yes, sir.
Yeah. So we were told that for us to get vector C, we needed to add vector B to vector A. So basically, A plus B is what gave us C. Okay. However, we also told that the size, we also told something, A and B are in the same direction. This one, they're in the same direction. So we don't have to worry about any angles. Okay. But one thing we told which is very interesting is that the magnitude of A was half the magnitude of B, which is what gave us this. A is equals to 0.5 B. So we substituted for A here, we replaced it with 0.5 B, and that's what landed us here. C is equals to 0.5 B plus B, and we ended up having C is equals to 1.5 B. When we got this, we decided to write this vector C in terms of components x, y, and z. So when you do that, Cx becomes 1.5 B, Cy 1.5, Cx 1.5 Bx, Cy 1.5 By, Cz 1.5 Bz. Then we knew the values of C, the components of C we've been given. Cx was minus 3 centimeters, Cy was plus 6 centimeters, Cz was plus 4 centimeters. So we could substitute for these values of C and work out the components for B. So here, for Cx was minus 3 centimeters. So minus 3 centimeters equals 1.5 Bx. So we work out for Bx and we found Bx to be minus 2 centimeters. Same, we substitute for By. So it was 1.5 By equals to Cy. And Cy is this guy, plus 6 centimeters. So we did that. Then we work out for By, make By the subject. Then work out for By, we found 4 centimeters. Then similarly, we did the same thing for Bz. 1.5 Bz equals to Cz, and we know the value for Cz is plus 4 centimeters. So we ended up having 1.5 Bz is equals to plus 4 centimeters. Then we work out for Bz is equals to plus 4 centimeters, 1.5. We ended up having this. Then we remembered that, so we had the components of B, or the components of B, but we remembered the fact that this A is related to B in this fashion. Okay, that's what we remembered. And that's what you have here. A is equals to 0.5 B in that fashion. So we could write A in terms of components, A and B in terms of components. So we end up having AX is equals to 0.5 BX, AY equals to 0.5 BY, AZ equals to 0.5 BZ. And we have the values of B in each of these cases. Okay. So we just substitute the values of B. For AX, it is minus 2 centimeters. We ended up having, for BX, it was minus 2 centimeters. We ended up having AX of 1 centimeters. For BY, BY was 4 centimeters, so we ended up getting a value of AY as 2 centimeters. AZ was 2.7 centimeters, so we ended up having a value of AZ as 1.3 centimeters. So basically, yeah, in this case, we kind of did not need a table because the vectors we're adding, A and B, were in the same line. Okay, the vectors we're adding A and B were in the same line, or they were in the same direction. So if you're adding vectors which are in the same direction, you do not need a table of components. Is that clear?
Yes.
Okay, so let us move on to question number 6. Now question number 6 shows us vectors which are in different directions, so we definitely do need a table here. Okay, 3 vectors A, B, and C are shown, and this is where they are. A, B, and C are shown like this. Next, find the magnitude and direction of vector D, which when added to these 3 vectors gives a resultant of 0. So we have got these 3 vectors: vector A, vector B, and vector C. Okay, then there's another vector vector D, which we need to add to these guys, to A, B, and C. If we add vector D, the result is going to be 0. Okay, so we need to find that. Now, for us to do this, the best way to do this, since each of these vectors is pointing in a different direction, then we do not even know where D is supposed to be pointing. We need a table. Okay, in this table, we are going to put, for each vector, we find AX, AY. For each vector, we find AX, AY. Even for D, then we add them. When you add them, we know that the resultant is equals to 0. This part, we're going to use this part. 0 resultant. So when you add AX plus BX plus CX plus DX, the result is supposed to be 0. When you add AY plus BY plus CY plus DY, the resultant is supposed to be equal to 0. Because if the resultant in the X direction, in the Y direction is not equal to 0, then you cannot have you end up having a resultant which is not equal to 0. Okay. So give me a minute to copy one of our tables and then you modify it so that we can use it for this particular calculation. Okay? Yeah, so I need a couple of minutes to copy a table somewhere so that we can go through this particular calculation and see what we get. I will always try to find a very, very simple way of solving these problems, because it's always possible. And if the method you're using to solve a problem is simple, then it's easy to remember and also easy to understand what's going on. You can also actually explain to some of your students, some of your friends. Okay. So components of, so we've got vector A. So you've got vector A, vector B, vector A at theta. We'll find out the angles at theta something. Then it would be let's see. Let's see. And D. Just a minute. It goes to the mid. Okay. A. There's A. And there's B. There's going to be C. See. Then there is a resultant. R. RX. Okay. So this is a table we have created. In this table, with vectors we need, there's vector A here, there's vector B, there's vector C, there's vector D, there's a resultant, and of course the resultant, we know that the resultant is going to be equals to 0. The Rx is equals to 0, the Ry is equals to 0. That's why the whole thing really, that's why you end up having a resultant of 0. That's okay. So when you look at the diagram, vector A, the size of, how much is vector A? The size? What's the size of vector A?
meters.
210 meters. And what's the angle it makes from the positive x-axis?
180.
180 degrees. So here, so our vector A, 210 meters at an angle of 180 degrees. Then we move on to vector B. What is the size of vector B?
180 meters.
180 meters. Meters. And what angle does it make?
45 degrees.
45 degrees. There. B, 180 meters at 45 degrees. Then we move on to vector C. What is the size of vector C?
110 meters.
110 meters. And what angle does it make with the positive x-axis in an anti-clockwise direction?
240 degrees.
240 degrees. Okay, so that's what you know. And of course, we have got an unknown. We have got an
Sorry, sir, I made a mistake. It's supposed to be 330 degrees.
330.
Yeah.
Okay. 330 degrees. Any questions on these angles and directions and sizes? Any questions before we proceed? Does anyone have a question about the size of the angle and the about the size of the vector and the angle it makes with the positive x-axis? Okay, so if there are no questions, then you're going to proceed to find the components of each of these vectors. So we have got A. The size of A is 210 meters at an angle of 180 degrees. So how do we get AX? How do we get AX? Before we find out what AX is, how do we get AX? How do we get AX?
I think the magnitude of A sine cos the angle it makes.
Magnitude of A cos the angle it makes. theta, and like that. And how much is the A, magnitude of A?
210 meters.
210 meters. Then cos, the angle is how much?
180.
180 degrees. And how much do you get? 210 times cos 180 degrees?
Negative 210.
Negative 210 meters. Clear. Next, how do we get AY?
The magnitude of A sine the angle 180.
Okay, the magnitude of A is and the angle. So that is 210 meters, then sine 180. And how much do you get for this?
0.
You get 0 meters. So 210 times sine 180, you get 0 meters. Is this clear?
Yes.
Okay. Next, we move on to bx. How do you get bx? How do you get bx?
The magnitude of B cos the angle.
Magnitude of b equals the angle. There. B equals the angle. How much is B?
127 point.
How much is B?
Sorry.
B. How much is the magnitude of B?
180
180.
meters.
180.
And how much is the angle?
45.
There. 180 cos 45. And how much do you get for that?
That is 136.87 magnitude.
136?
It's 127.3.
Which one is correct?
127.3.
127.3. Is that correct? Can someone else confirm?
Yes, it is.
Okay. Next, we move on to BY. How do you get BY? How do you get BY? Sorry?
I'm going to do 180.
How do you get BY? How do you get BY?
45.
How do you get BY?
We're going to get 180 sine 45.
How much is 180 times sine 45?
127.3.
Okay. We move on to CX. How do we get CX? How do we get CX? How do we get CX?
The magnitude of C
Mm-hmm.
cos the angle.
Okay. The magnitude of C equals the angle. That. And how much is the magnitude of C?
110 meters.
110 meters. And how much is the angle C makes?
330 degrees.
110 meters, 330 degrees. There. 110 meters, 330 degrees. How much do we get for that?
95.3
95.3
or meters.
meters. Yeah, okay. Then how do you go about getting CY? How do you get CY?
The magnitude of C
Mm-hmm.
sine the angle.
Magnitude of C is and the angle. Yeah. Then how much is the magnitude of C?
110 meters.
110 meters. And how much is the angle we're dealing with?
330.
330. Then 110 sine 330 degrees. How much we get?
Negative 55.
Negative 55. Okay. So looks like we have managed to get, for vector A, vector B, and C, we have managed to get the x components and the y components of vector A, B, and C. When we come to vector D, do we know anything? Do we know the size of D?
No.
Do you know an angle of D?
Nope.
No. So basically we just write D cos theta, whatever theta is, for the dx. Yeah, whatever it is, we will find out. If that's what they want us to find out. Then the other one is D sine theta. And of course there is no harm in not knowing what this stuff is at the moment, because we'll get there. Is that clear? So that's what we know about dx. We just know that it is the size of D, then cos the angle it makes, then the size of D and the angle it makes of the dy. Okay. Then the other bit is Rx. How do you find Rx? How do we find Rx and how much is Rx? The first part, how do we find Rx? R is the resultant. So how do you find the x component of the resultant?
We add all
We add what? How do you find Rx? Hello? Have you all disappeared? How do you find the resultant of the x component of the resultant? What have you been doing? How do you find the Rx?
You add the components.
Which components am I adding?
X components.
Of what?
I think of A, B, C,
And what?
the X components of A, B, C, and D.
Yes, we add the x components of A, B, and C, and D. So it will be AX plus BX plus CX plus DX. And we are told this is equals to how much? How much is Rx? How much is Rx? What are we told in the question? We'll give resultant of what?
0.
0. So if the resultant is equals to 0, how much is Rx? Yes, 0 meters. For you to have a resultant of 0, it means that the x components of the components of the resultant have to be equal to 0. Okay. Zero meters. That's okay. Similarly, how do we find RY? RY is how much? How do you find RY?
You add all the Y components of A, B, C, and D.
So we add the Y components of A, B, C, and D. And how much is ROI? It's also equals to 0 meters. Is it clear to everyone why these components Rx and Ry are equals to 0?
Yes.
Okay. So if you look at this, Rx is equals to 0 meters, Ry equals to 0 meters, but we have Ax, which is what this one, By, which is that one, which is that. So if you substitute these guys here, we can work out for Bx, for Dx. Similarly here, there's a 0 there, there's a By there, there's that guy there. So if we substitute in R this, then we can work out dy. Is that clear?
Yes.
So that's what we're going to do. Okay. So we work out for dx as follows. So we get dx rx there. So which is that. Okay, so we substitute for ax bx and cx gets following. So when we substitute, just a minute. So our ax is, where is that? Where is ax? There. 110. Sorry, 210. That will be our ax. 210 meters. Our bx.
127.3.
Yes, 127.3. Then our cx is this guy here. Okay, so get that. So minus 210 meters plus 127.3 plus 55.3 meters. How much is this lot here?
12.6.
Okay. $12.6. Yeah, 12.6 meters plus dx. Therefore, we get dx. So dx, just a minute. So our dx will be how much?
Negative 12.6.
Yes. Negative 12.6 meters. Similarly, we work out dy is going to be there. There. Then we get these. Then we substitute. Just a minute. For ax, for ay, by, and cy. So yeah, when you substitute there, now let's do this substitution. How much is our ay? How much is ay?
210.
Ay?
It's 0.
0 meters. I think you need that table there. Then how much is our by?
127.3.
127.3. Then how much is our cy?
55.
50 what?
Negative 55.
Oh, okay. Negative. There. So we have 0 meters plus 127 meters plus minus negative 55. So how much is this lot?
72.3 meters.
72.3 meters. .3 meters. There. 72.3 meters plus dy equals to 0 meters. Therefore, how much would be our dy?
Negative 72.3 meters.
So dy will be negative 72.3 meters. Like that. Is this clear? Oh, sorry. There's a plus somewhere, which is not supposed to be there. Is what we have done clear? Now we know what dy is, what dx is. Is this clear?
Yes.
Okay. So let's go back again. So we started with figuring out the angles for each of these vectors from the positive x-axis going like that. So for vector A, the size was 120, the angle was 180. For vector B, the size is 180, the angle 45 degrees. For vector C, the size is 110, the angle all the way down like that was 330. and we worked out the components for A, B, and C, like that. This is how we worked out the components, the x components and the y components. Then there was a vector D, which we did not know what it was, but so we just did that. Say, okay, dx, the best we can do is whatever the size of D is, then the cosine of the angle it makes, whatever the size of dy is, then the cosine of the angle it makes. Then the resultant, we're told the resultant is 0. So for us to get the resultant, you need to add the x components of all the vectors which are involved. And since the resultant is 0, the Rx is going to be equal to 0. And same thing applied for y. So we proceeded to do this, make the substitutions, work out for dx, work out for dy. Okay. Any questions? Questions? Okay, so if there are no questions, I think it is easier for us to jump to question number 8. I think we can easily work out question number 8 so that we only remain with question number 7. Okay, so that's exactly what you're going to do. So you're going to jump question number, we'll jump to question number 8. Work out question number 8, then if you have time left, we can try to come back to question number 7. But I think if we do question number 8, means that we are left with only one question, which we can do tomorrow at 18. Is that a plan? We can do it?
Yes, sir.
Okay, so let's me copy a table. We need a table. Number 8. Okay, let's see. These kind of questions that impossible to work out if you don't have a table. But if you've got a table, they're very, very straightforward to work out. Okay. So in our table, just a minute. Give me some time to kind of clean up things from the other table from using. Now, if people write chat messages, I don't look at chat messages. It takes me a long time to look at the chat message. It takes me quite a long time to look at the chat. Okay, table is a bit clean. So what do we have? So the question says, question number 8. While exploring a curve, a person starts at the entrance and moves the following successive distances. Okay, she moves 75 meters north. So this is the first distance. We'll call that D1. Yeah, let's call that D1. So D1, the first distance she moves, call that D1. 75 meters. 75 meters north. We'll work out the angles later. Let's just get the information we need. 75 meters north. Then 250 meters east. That would be our D2. So distance number 2. D2. 250 meters east. Again, we'll work out the angles later. Then 125 meters at an angle of 30. It's supposed to be 30 degrees. Why did that? At an angle of 30. Just a minute. Degrees. 30 degrees north of west. So that is 30 degrees north of west. That's pretty clear. So that is 125. That is D3. D3 is 125 meters at 30 degrees north of west. At 30 degrees north of west. We will figure out the angles again later. And 150 meters south. So there will be a D. There will be a D4. D4 is equals to 150 meters south. Okay, so these are the distances we have. Table number 6, components. D1 is 75 meters north. D2 is 250 meters east. D3 is 125 meters at an angle of 30 degrees north of west. D4 is 150 meters south. So I need to change in my table here. So I need to have D1. Then I need to have D2. Let's have D3. Let's have D4. Like that. Yeah, so D1, D2, D3, D4. Then the X components will be D1X, D2, D1Y, D2X, D2Y. So then those will be the X components. Then the other ones, D3X, D3 Y. Then the other one is D4X, D4Y. Okay, so that's how we're going to do that. Is this table clear?
Yes.
Okay, so for each vector, D1, D2, D3, D4, for these vectors, we know the sizes, okay? The only thing left which we do not know properly in terms of angles are the directions, okay? So we go back, we assign directions. How much is, what direction is north? What angle is north? For D1, how much is theta?
I think 180.
D1 here. 75 meters north. So how much is that angle? Remember, we always measure the angle from the positive x-axis. So if you're looking north, how much is the angle?
90 degrees.
90 degrees. There. Theta is 90 degrees for D1. Then for D2, what is the angle? D2 is east. How much is the angle? Between D2 and the x-axis, how much is the angle? How much is the angle D2 makes?
Degrees.
D2 makes an angle of 0 degrees. Yeah. Then D3. D3 we are told at an angle of 30 degrees north of west. How much is that? $30 degrees north of west.
I think the angle is 45.
How much?
45 degrees.
How much?
45 degrees.
45 degrees. No, it's not 45 degrees.
Is it 60 degrees?
150 degrees.
How much?
150.
150 degrees. How did you get the 150 degrees?
180 minus 30.
180 minus 30. Okay. Is that clear? West
Yes.
is at 180 degrees. So if you go north of west by 30 degrees, you subtract from the 180 degrees, you subtract 30 degrees. You end up with 150 degrees. Then south, what angle? D4, what angle does it make?
Should be 180 plus 90.
Which is how much?
270 degrees.
270 degrees. Is this clear? The directions, the angles, the directions and the angles. Is that clear?
Yes, sir.
Okay, so with us having all these vectors, all these distances d1, d2, d3, d4, in their directions, we can proceed to work out the components of each of these distances. Okay, so we start with d1x. How do we get d1x? How do you get
75 cos 90, which is cos 90.
75 meters?
So that should be 0.
Just wait, 75 meters. Cos 90 degrees.
Which is 0. Is it?
75 meters cos 90 degrees. How much do you get for that?
0.
0 meters. That is d1, then cos the angle. There. d1 cos the angle it makes, which is the d1 is 75 meters, the angle it makes is 90 degrees. Then we move on to dy. How do you get that? How do we get
75?
How do we get
75 sin 90, which is equal to 75.
Okay, then move on to d2x. How do you get d2x?
It's 250, which is 250 cos 0, which is 250 meters.
250. So d2 cos the angle. Okay. Just a minute. Okay, 250 cos 0 degrees, how much?
250.
250. Then d2y.
250 sin 0, which is 0.
Sin 0. 250 is 0, which gives us how much? How much we get?
0.
0.
42. 0.
Okay. So D1x, D2x, D1y, D2y, those are sorted. We move on to D3x. How do you get D3x?
125 cos 150, which is equal to negative 108.25.
I have to type, just wait a minute. So D3 cos theta 125 cos how much?
Cos 150.
Cos 150. Okay. Sorry, 125. I've written 120. 125. 125 cos 150.
Yes.
That's how much?
Negative 108.25 meters.
108.25
meters.
That's 3, basically. What have I done? I think I've made a mistake somewhere. D3.
This is for that one is for the D3x.
Just
the
wait.
negative.
Just wait. Yeah. Just a minute. It's supposed to be this side. Okay, that has been fixed. Then D3y, how do you find D3y?
125 sine 150.
Okay, just a minute. Okay, 125 and 150, what do you get?
62.5 meters.
5 meters. Okay, there we are. Then we move on to D4x. Those people at home, what are they discussing? D4. How do you get D4? D4x?
150 cos 270, which is 0.
150
Cos 270.
cos 270. Okay, which is 0. Then on the other one, D4y.
150 sine 270.
Okay. D4. How much is that?
Negative 150 meters.
Negative 150 meters. Okay. Okay. So it looks like we have managed to get all the components, D1x, D2x, D3x, D4x, D1y, D2y, D3y, D4y. The next bit is the resultant. How do we find Rx? How do you find Rx?
By adding up all the components, the x components.
Which one are those?
0 plus 250
No.
minus 108.
No. The names of the names of the x components. What are the names of the components you're adding?
The D1x, D2x, D3x, and D4x.
Plus D3x plus D
Abracadaboo, Chanda, eh. Dakanda, eh.
Hey, Sarah, what are you doing? Okay, by doing that, then how do we find the ROIs? The guy who is talking, can you tell the people at home to shut up a bit?
Okay.
Yeah, tell them to lower down their voices a bit.
Okay.
Yeah, go. So we'll wait for you. We can't tell them to lower down their voices.
So for the
Yes.
ROI, the components, the answer is negative 12.5 meters.
How did you get that?
We add up all the components. That is D1y, D2y, D3y.
What are the sizes of the components? What are the sizes?
The sizes, D1y is 75 meters.
Which one are you adding?
The components.
The X components?
We are done with the X components. Now we are going to the Y components.
No, we are trying to work out what the size of the. You look at the table. We are trying to work out what the actual size of Rx is. So we need to replace D1x, D2x, D3x, D4x with the actual size, the actual values.
Yes, the answer is 141.75.
So the values are what?
The values are 0 plus 250 meters.
Just wait. 0 meters.
0 meters
Okay.
plus 250 meters
plus 250
minus 108.3
meters plus negative 108.3
8.3 plus
meters
0 meters.
plus 0 meters. So that gives you how many meters?
141.7.
141.7?
Yes, 141.
Just a minute. Oh, yeah. Okay, so we get that. I think I need to add another line. Then for the ROIs,
Otherwise, we add up all the components. The first one,
Is
that
what?
is D1y is equal to 75 meters.
75 meters.
D2y, 0 meters.
Meters plus 0
meters.
meters.
And then D3y is 62.5 meters.
62.5. Just a minute.
D4y,
Just wait.
negative.
Just wait. Meters plus the fourth one is
The
what?
fourth one is plus negative 150 meters.
150 meters. That gives us how much? How much?
Negative 12.5 meters.
Negative 12?
12.5 meters.
Okay, so I need to do something to create more space. Make sure the table is more spacious. Okay. All right. So it looks like our table is complete. We have everything we need. We have got the x components, we got the y component. The x component of R is positive, so it lies along the positive x-axis. The y component of R is negative, it lies along the negative x-axis. So, is that clear to everyone?
Yes.
Okay, so somewhere, all right. The x component, of the resultants, the displacement, Rx, x is positive, so it lies along the positive x-axis and x-axis. The y component of the resultants displacement, which is ROI is negative, so it lies along the negative y-axis. The resultant vector, therefore, resultant displacement R just a bit R lies in the fourth quadrant. Okay, so at least we know where R is now from looking at the components. When you look at the component here, when you look at the components, the x component of R is positive, so this one lies along the positive x-axis. The y component is negative, so this one lies along the negative x-axis. Therefore, R must lie in the fourth quadrant. Okay. So the question we are told we need to do what? What are we asking us to do? Find the resultant displacement. We need to find the resultant displacement from the center of the cave. So for us to find the resultant displacement, we need to find the magnitude of R. We also need to find the direction of R. So the magnitude of the resultant displacement R is given by Can you kindly switch off your microphone? Both are? Okay. Alright, so how do we find R? How do we find the resultant of R?
We find the resultant by the formula square root of Rx squared plus Ry squared.
Okay, so square root of Rx squared plus Ry squared. There. Square root of Rx squared plus Ry squared. And we have these values. So we will substitute. So how much is our Rx? How much is Rx? Hello, people, how much is Rx?
141.7.
Okay, and how much is Ry?
Negative 12.5.
Yeah. Then what do you get for that? What do we get?
This your
141.1.
How much?
142.25.
142.25. Which is what? 3. Yeah. Is that clear? So everybody?
Yes.
Okay. So now we move to the direction. Okay. So the angle resultant vector max with the positive x-axis can be measured using two directions or angles. The first angle is theta, measured from the positive x-axis in an anti-clockwise direction. The second angle is phi measured from the positive x-axis in a clockwise direction. These two angles theta and phi are related as follows. First of all, here. So the angles, so the theta and phi. What is missing? So there's theta and phi, and these two angles are related as follows. So again, equation: theta is equals to 360 degrees plus phi. So that's a relationship. So we need to find phi. Okay. First, we need to find phi. As follows. How do you find tan phi?
Ry over Rx.
Ry over Rx. Yeah, I thought. And we have values for Rx and Ry. So how much is our Ry? How much is Ry?
12.5.
How much?
Negative 12.5.
Negative
12.5.
Okay, negative 12.5 meters. Then how much is our Rx?
141.7.
Okay. That gives us how much? How much you got? It's minus
minus 0.0882.
0.088.
82. 2.
Okay, that's fine. Minus 0.088. Like that.
Yes.
Okay, then work out phi. So we get phi as how much is that? Phi is equal to tan inverse of minus 0.088
Negative 0.029.
0.029
29.
degrees.
Yes.
Okay. Then get theta.
So it should be negative 5.
Where it's supposed to be negative 5. Negative 5 degrees?
Not negative 0.
Negative 5 degrees.
Yes, negative 5.029.
5.029. Okay, basically 5. Okay, approximately negative 5. Approximately negative 5. Okay, degrees. So we get theta as so theta and so how much do you get for theta? 355 degrees. Yeah. Are we clear?
Yes, sir.
Okay, so I think now it's the time is 11:20 and we're supposed to end at 11:13, so we have run out of time to do anything else. So we are going to stop here. I will proceed to upload the PDF to Moodle under the first topic as usual, as I've done. So you access the PDF from there, where this question number 8, and the other question, I think, the other questions I've done have been sorted out. Then I'll also upload the recording to YouTube for your friends who did not access thing. So again, once the recording to YouTube has been done, I will share the link in Moodle, so you should be able to access the stuff from there. Unless there are any other questions, I'll wait a bit. You can ask questions if there are any questions which need to be asked. But if there are no other questions, then we'll finish up question number 7, which we skipped, tomorrow. Which means if we finish question number 7 tomorrow, on Wednesday, we should be able to start the next tutorial sheet on Thursday. Is that a plan we can work with?
Yeah, sure.
Okay. All right. So I'll see you tomorrow. And in the meantime, let me get on with trying to upload this stuff.